Welcome to the deep dive. It's the 2nd of February 2026 and we've been digging into the Google Cloud updates from the last 2 weeks of January.
And there's a lot to cover.
There is, and our mission today is to sort of connect the dots. We're looking at a key problem that every cloud provider is trying to solve.
Which is?
This massive gap between having this incredibly powerful technology and then making it genuinely easy for you to actually use.
That's the perfect way to frame it actually. Because the updates we're seeing, they're not just some random list of features. It's a proper effort to bridge that exact gap.
Right.
Whether you're a data analyst who doesn't code or a developer trying to launch an app without, becoming a full-time infrastructure engineer, the theme is the same.
It's about hiding the complexity.
Exactly. Abstracting away the complexity and embedding intelligence right where you work.
Okay, so let's unpack this. The most obvious place to start has to be artificial intelligence. It's no longer this separate, intimidating thing you have to go and learn.
Correct. It's being woven directly into the tools that you're probably already using every day.
So think of it less like a new product and more like a new skill for your existing products.
Precisely. And we are seeing a two-pronged strategy here. First, make AI accessible to people who don't write code.
Okay.
And second, embed it even deeper into the toolkit for the hardcore developers and data scientists. They're tackling it from both ends. And the first example is a big one, BigQuery.
Right. So for anyone not familiar, BigQuery is Google's massive fully managed data warehouse. You pour just unbelievable amounts of data into it.
Petabytes of it.
And it lets you ask questions of that data at lightning speed. But traditionally, asking those questions meant writing SQL.
A specific query language, yeah.
And this new feature, Conversational Analytics, promises to change all that. You can just talk to your data in plain English.
The promise is huge, yeah. Instead of you needing to write some complex multi-line SQL query.
With all the joins and aggregations.
All of that. You can just ask, compare our revenue from top-selling products in the North and South regions for last quarter. And it's supposed to generate the answer, the SQL, and even charts.
Okay, my skeptical practitioner hat is on now. We've seen natural language things before, and they can be a bit brittle. You use the wrong word and the whole thing breaks.
Correct.
How smart is this really? Is it just a fancy keyword search, or does it get the business context?
You've hit on the key challenge, and they've addressed this with a clever two-step process. It's not just a free-for-all chat box.
Acha.
First, a data analyst or developer who does understand the data has to create what they call a custom agent. They point it at the right tables, give it instructions like, when a user says revenue, use this specific column.
So it's not a general AI trying to guess things. It's a specialist AI that has been trained by an expert on your specific data.
Bilkul. Then they publish it. So a business user comes along, finds this agent, and can start asking questions, knowing it has the right guardrails.
That makes a lot of sense. It democratizes access without creating a mess of wrong reports.
Exactly. It's a very practical solution to that exact brittleness problem.
Okay, now this is where it gets really interesting for the more hands-on developers, especially those running heavy AI workloads. Data flow.
Which is Google's service for building data pipelines.
Right, that got some major efficiency boosts. It now supports the latest powerful hardware like NVIDIA H100 GPUs and Google's next-gen TPUs.
And this isn't just about raw power. It's about, intelligent access to that power. For instance, you can now reserve hardware for a critical job. But the most subtle and maybe more important update is a feature called Flex Start Provisioning.
Okay, so what problem is that solving? I know if you request a specialized GPU and the region is out of stock, your job just fails?
That's exactly it, which is incredibly frustrating.
Totally.
Now smartly enters a queue and just waits. As soon as the hardware is free, the job starts automatically.
So it turns a hard failure and a late-night alert into just a short managed delay.
That's the idea. It's a huge quality of life improvement.
But does that delay have a knock-on cost effect?
That's a fair point. The delay itself doesn't cost you compute, but they've paired this with another feature called right fitting, which tackles the cost side directly.
Okay, how does that work?
Basically, you can design your pipeline so that only the steps that need an expensive GPU get assigned to a powerful, costly machine. The other parts, like simple data loading, can run on cheap standard CPUs.
So you're not renting a Lamborghini for the entire trip.
Perfect analogy. Just for the 1 mile stretch where you can actually use the speed.
And this idea of embedding AI power directly where you work, it goes even deeper inside BigQuery, right?
They've added a whole new set of SQL functions powered by Gemini 3. So you can call the AI directly from a line of SQL.
What does that look like in practice, matlab?
Imagine a table of product listings. One column has text, another has an image. Using a simple function like AI.generate, you could create a new column on the fly with a catchy marketing summary for each product.
Wow, okay.
And with AI.embed, you could create vector embeddings of the image to find visually similar products, all from a SQL query, without moving the data.
So, making data analysis more accessible with AI is one piece, but all that data has to live somewhere, and it needs to be fast, which brings us to databases.
Yes, and the big theme here again is abstracting complexity, starting with AlloyDB.
AlloyDB is Google's high-performance Postgres-compatible database.
Correct. So you get the familiar feel of Postgres, but with much better performance. The big news here is a built-in managed connection pooler.
Now, for anyone who hasn't had the pleasure, managing database connections is a nightmare. If your app opens too many, you can crash the database.
It is a headache. Anyone who's had to configure something like PG Bouncer knows it can take a whole weekend just to stop your app from falling over on Monday morning.
So by making this a built-in managed feature, Google is just taking that entire burden away.
That's it. And the numbers they're quoting are pretty eye-popping. Up to 5 times higher transaction throughput.
Okay, but we all know benchmarks can be a bit optimistic. Who actually sees that kind of benefit?
That's the right question. The 5x number is likely from a perfect fit workload, like a serverless app that creates thousands of very short-lived connections.
Right.
But even if you're not in that perfect scenario, the other benefits are universal. They're talking about supporting over 3 times more concurrent connections and making your app far more resilient to traffic spikes. That stability improvement is something everyone will feel.
And this same philosophy seems to extend to Firestore as well.
Firestore, which is Google's flexible NoSQL database, super popular for web and mobile apps. It got a major query engine upgrade.
And the headline features that queries can now run without you needing to create an index beforehand.
Which is a massive deal for developer speed, yeah? In the past, if you wanted to query your data in a new way, you first had to go and build a specific index. Now you just write the query and it runs.
But my immediate thought is performance. That sounds flexible, but aren't my production queries suddenly going to slow down?
You've pinpointed the exact trade-off. For prototyping, it's a dream. For high-traffic production queries, you will feel that pain.
So what's the solution?
That's why they didn't just release the feature in isolation. They also released new tools called Query Explain and Query Insights. These tools analyze your queries, show you exactly how they're running, and then explicitly recommend where an index would be most beneficial.
Acha, so they are giving you the freedom, but also a diagnostic toolkit to tell you when and where to build a safety net. That's a smart balance.
It is. It's about empowering the developer, not just protecting them.
All this speed in the data layer is great, but it's only as fast as the infrastructure it runs on. This brings us down the stack to compute, starting with Google Kubernetes Engine, GKE.
Right. GKE is how so many people run their containerized apps. The autopilot mode in particular just got a huge speed boost.
How so?
By parallelizing how it creates new groups of machines or node pools, the time it takes for your apps to scale up has been slashed.
And the metrics here are genuinely impressive. Their test showed an 85% reduction in time for scaling a workload from 0 to 30 nodes.
Even at a much larger scale, from 0 to 200 nodes, the reduction was still 62%. And this isn't just about your website loading faster. Think about the AI workloads we discussed.
Right, an AI model might need to scale to hundreds of GPUs in seconds.
Exactly. This kind of speed up in GKE AutoPilot is what makes production AI practical and cost-effective.
Speaking of cost-effective, let's talk about the machines themselves. Google's custom ARM-based Axion processors.
They are now generally available in the N4A machine series. And the big headline is up to 2 times better price performance compared to equivalent x86 machines.
This is a really important optimization level, isn't it? For so many modern workloads, web servers, microservices, things written in Java or Python, the underlying processor architecture doesn't really matter.
Correct? They are not tied to x86. So being able to switch to these ARM-based machines can lead to significant cost savings.
But how hard is that switch really? Do I need to recompile my whole application?
That's the beauty of containers. For most apps, the switch is often trivial. In your Kubernetes config, you're basically just changing a single line, the node selector, to tell it to deploy on an ARM machine. The barrier to adoption is incredibly low.
So we've covered the tools for data, databases, and infrastructure. But how does all this change the day-to-day life of the people actually building and securing these systems?
Let's start with security, because as AI gets more powerful, it introduces new risks. Google's Cloud CISO released some really practical guidance on this.
It wasn't about specific tools, was it? It was more of a mindset shift. Exactly. 3 ideas stood out. First, treat your data as the new security perimeter. Second, treat user prompts as if they were executable code. And third, know the identity of the AI agents accessing your systems. That second one, treat prompts like executable code, is fascinating. What does that mean in practice?
It means a cleverly crafted prompt from a malicious user can do real damage now. It's the new SQL injection attack. A bad prompt could trick an AI into ignoring its instructions or revealing sensitive data.
So you have to validate and sanitize prompts with the same rigor as any other user input.
Bilkul. It's a fundamental shift in how we think about security boundaries.
And AI isn't just something to be secured, it's also a tool to help us work better, like how Google's own site reliability engineers are using the Gemini CLI.
This is where it gets very real. Imagine it's 3 a.m. and alert fires. Instead of digging through old documents, you can ask the CLI, "This alert just fired. What does it mean, and what are the first 3 steps to mitigate it?"
It's an expert assistant, available 24/7, right in your terminal.
It can even help you write the post-mortem document after the incident is over. And that bridges us to the final piece, getting your own AI ideas into production. The new guide about building an app in AI Studio and deploying it to Cloud Run with a single click. And Cloud Run is Google's serverless container platform. So you just give it your code in a container and it handles all the scaling for you.
That one-click deployment just removes that final massive barrier between a cool prototype and a live scalable application.
It closes that gap we talked about at the start. It lets a developer focus on the application logic, not the infrastructure complexity.
So as we wrap up, it feels like the big takeaway isn't just one single feature. It's that central theme, na?
It is. AI is becoming a universal toolkit. Core services are getting faster and smarter, and the daily work of developers is being augmented by AI assistants.
To go deeper, Google has released a new free production-ready AI learning path.
And a specific 2-hour course on that Gemini CLI we just talked about.
We leave you with a final thought to mull over. We started by talking about conversational analytics in BigQuery, where you can ask questions in plain English.
Right.
So think about your own projects, your own team, and the data you have. With a tool like that, what is the one critical question you've always wanted to ask, but never knew how to write the code for? The answer might be closer than you think.